In this video, we're going to talk about resonance structures. We're going to cover the basic principles, then we're going to talk about how we can draw resonance structures, and then we're going to look at how we can evaluate the different resonance structures that we draw. To cover some of the basic principles of resonance structures, what we're really looking at when we draw resonance structures is two different pictures of the exact same species. The only thing that we're doing is we're changing where the electrons are in our species. And we can denote that change of electrons by using some arrows in our picture. So we're making a double bond here, we're breaking this double bond to put the extra lone pair in that case. So that's one of the key things that we want to remember, is we're only making and breaking pi bonds. The sigma bonds are going to remain intact. In fact, if you start to change the sigma bonds, it's no longer a resonance structure. We can only make and break those pi bonds. We can utilize lone pairs that we have adjacent to our pi system as well. It's important to recognize that this is not an equilibrium between these two. These are just two different pictures of the exact same species. A better structure that we could draw is something called a resonance hybrid. And in this case, if we try to draw a resonance hybrid, we have partial double bond character between all of these atoms. We have a partial negative here and a partial negative here. This is a better picture of what the species looks like as a whole, but we tend to draw one of these different resonance structures depending on the type of chemistry that we want to talk about. In the next section, we're going to cover some tips on how we can draw resonance structures. So here are two different cases where we can draw resonance structures. In the first case, this is the exact example that we had on the previous section. We have a single or a lone pair of electrons with a negative charge, and we're one bond away from a double bond. If we have a situation like this where we have a lone pair or a negative charge, we always want to push the electrons towards that pi system to make our new double bond, and then break that pi system to put that lone pair on the next atom. So our resonance structure, when we're completed, has the new double bond and then the new lone pair. In our second case, we have a positive charge on an atom that's one bond away from a pi system. And in this case, we want to push the electrons towards that positive charge. So we're going to start off at our pi system, take those pi electrons to make the new double bond here. By doing this, that's going to leave the other atom, the other carbon, electron deficient. So now we have a positive charge on that carbon. It's important to recognize this one bond relationship to our pi system. If we look at another example, here I have a negative charge and I'm two bonds away from that pi system. We can't draw any resonance structures for this particular one. We could try, some people would like to try to do this, or try to move that lone pair over. But if we do that, there's a couple things wrong with this structure. We no longer have the same charge that we had before, and we're forgetting about some of the key structural elements that we had in this structure. There are two hydrogens that are here. These hydrogens are implied in the line structures that we're using, so they would still be there in that structure. Now right now this carbon has 10 electrons around it. There's too many electrons that can be accommodated by that carbon. So this is not going to be a valid resonance structure. This is not a good structure. But if we follow this rule of pushing electrons towards pi systems, or taking those pi electrons and pushing them towards positive charges, we should be able to get very good resonance structures. In the next section, we're going to learn how to evaluate the different resonance structures that we can draw. So now let's take a look at evaluating some structures. And I want you to be able to play along at home as well. So I've given you a structure here. Take a few moments and try to draw as many resonance structures as you can for that. You can pause the video while you do this, and then I will go through and look at the different resonance structures, and we'll talk about the different ones. All right, so let's take a look at what we have. So we can take our lone pair here with our negative charge and push it towards the pi system like we talked about before. And that pushes another lone pair onto that carbon. That's one more valid resonance structure. But we can keep doing that. We have another pi system here. So I'm going to continue to move that lone pair of electrons around my structure. So these are 3 resonance structures that we can draw, but it's not the only ones that we can consider. If we take this first one, there's a different structure we can draw where I'm just going to push those electrons up to the oxygen. I didn't involve the lone pair that I had down here. Let's see what that gives us. And we can do something similar with either of these other ones as well. So we'll do the second one here. I'm just going to use basically the second arrow, not the first arrow. So let's see what we have. One thing you might notice right away for these extra resonance structures that I drew down here is we went from 1 charge now to having 3 different charges in our structure. This is an indication that these resonance structures may not be playing a big role in the overall picture of this species. So these are definitely not contributors to our overall picture. That's one thing that you want to avoid is those extra charges. So we want to avoid that separation of charge. The other thing that's really bad here is the carbon that we have in each of these structures only has 6 electrons in it. So we violated the octet rule for both of those. So we want to make sure that we're watching that octet rule as well. So in our overall picture, I would not be considering these 2 as good resonance structures. These top 3 are actually really good resonance structures that we need to consider, and they are what we call contributing resonance structures to the overall picture of the species. However, there is a difference. If we look, we have the negative charge on the oxygen in this species, and in these 2 species, that negative charge is actually on the carbon. By putting the negative charge on the oxygen, this is the more electronegative atom, and it would rather have that negative charge. So of these 3, this is probably the best resonance structure that we can draw. And these 2 here are going to be minor contributors to the overall picture. So hopefully by looking at these, we get an idea of which resonance structures are going to be useful, and hopefully you'll find this useful as you're starting to practice drawing resonance structures on your own.